Hello everybody and welcome back to another TerrNav video. Today we're going to be talking about compass error because correcting compass error is kind of important if you think about it. So we're going to go over a whole bunch of different types of problems. They're all Coast Guard license questions that could be asked. And there's different problems that ask different stuff, so we're going to kind of go over the different types of problems that you're going to see. So to get started, we've got this one here, and this one's saying that we were going 142 degrees per gyro compass with a gyro error of 1 degree 1 degree east, variation 8 degree west, and we were trying to find our course per standard compass. And we're given this deviation table, and that's going to come in handy later. So a lot of people teach it horizontally. I learned it vertically, and so the way I do it is gyro error T V M D C. And there's the mnemonic can dead man vote twice. Well, there's a mnemonic for this, but it's not politically correct, so I'm not going to mention it. So let's put in our information. So we know that our gyro is 142. Our gyro error is 1 degree east, variation 8 west, and we're gonna have to find that, and we want to find our course. So the best way that I think about this, they say true, greater, east, and that's definitely helpful for up here, but when I think about things in general, if I'm going from true down, because true is greater east, I'm always going to be subtracting east and adding west. When I'm going up, I'm going to be adding east and subtracting west. Now that doesn't apply up here because it's flipped for up here basically. So true is greater east, so this is going to be 143 degrees. And then remember our add west, subtract east, because true is lesser west. So 143 plus 8 is 151. So we're given this 151 degrees here. And you notice that 151 isn't on here, and it's basically saying that anything greater than 150, or in that 150 range, is going to be 0 degrees deviation. So we have 0 here. Now, usually it's not that easy. You have to do some interpolation. We're going to get into that later. And so that means that per compass, because we're not adding or subtracting any deviation, so it's 151.0 degrees per standard compass. Okay, so that's a slightly harder type of problem. Most of these problems are just plug and chug. So in this situation, we have a track line that's supposed to be 274 degrees true. Our variation's 4 east, deviation 2 east, gyro error 1.5 east, and we're trying to figure out what our course per gyro compass is. So we're going to write out G, E, T, V, M, D, C. And we're going to plug in the values that we know. So 274 degrees true, variation 4 degrees east, deviation 2 degrees east, gyro error 1.5 degrees east. I'm trying to find per gyro compass. Now, they give you these two values as a bit of a red herring. You don't actually need any of them. Because if I'm trying to go from true to gyro, all I have to do is just apply the gyro error. So everything down here is effectively irrelevant. So I just have to figure out, because true is greater east, what plus 1.5 gives me 274. And of course, that is 272.5. And that you make sure you gotta label everything degrees per gyro compass. So that's a pretty easy one. Okay, so let's do another one. Again, starting G, E, T, V, M, D, C. We're trying to figure out our true course. We're given that we're going 75 degrees per standard compass, so 0.75 degrees per standard compass. Variation is 10 degrees west, deviation 5 degrees east. And we remember, and we don't need gyro or gyro because we're not dealing with that here, so we can cross those out. And we remember from earlier, when we go down, we're subtracting east, we're adding west. We're going up, adding east, subtracting west. And that's, again, because true is always greater east. We're going up this way, so I have 0.75, we're adding east, so 0.80, and then we're subtracting west, So 070. And what do you know? 070.0 degrees true. All right, let's do some more. This is like a practical example here. So it says that you see range lights dead ahead bearing 343 degrees according to the chart. Variation of the area is 5 degrees west. And if you're steering on course 344 per standard compass, what is the deviation in your area? So G, GE, D, V, M, D, C. And again, we don't need these two because we're not dealing with gyro here. So true is 343, variation 5 degrees west. Magnetic, we'll calculate that in a second. Deviation, we'll calculate that, 344 degrees. So remember, when you're going like this, you are subtracting east, you're adding west, and going down in this situation. So we're adding west, 348 compared to 344. Well, I've gone down here, which means that my arrow has to be east, and I've gone down by 4, so it must be 4.0 degrees east. All right, let's do more. This is a more complicated example. It's going to talk about leeway, and I'm going to draw a little diagram for you in a second. So start off G, G, E, T, V, M, D, C. So we're on 125 per gyro compass. Gyro error is 1.0 degrees west. Variation is 6 east. Deviation is 2 west. And we're trying to figure out the course made good. Well, again, these are kind of the variation, deviation, or red herrings here because when you're dealing with leeway, you're only dealing with true. So we can forget about everything down here. And we know that it's west. True is less west, so 124 degrees true. Okay, so let's draw a diagram here. 124 degrees is somewhere over here. And I have a southwest by south wind, which is pushing me from like over here this way. So I'm allowing it. It just says find your true course made good. It's not telling you to correct it. So it's going to blow me up by 3 degrees. So if that's 124 minus 3 is 121 degrees true. That's going to be my new true course made good. Okay, so let's do this again, except we're going to correct for leeway this time, and then we're going to find what that course should be per standard compass. If we are going 124 degrees, and we're getting blown off course 3 degrees, getting us to 121, that means I need to go 3 degrees in the other direction, meaning that my new true course is going to be 127, because when I get blown those 3 degrees off course, I'm just back to 124 again. So T, V, M, D, C. We know that the variation here is 6 east, deviation's 2 west. So 127, true is greater east, so that's 121. True lesser west, 123 degrees per standard compass. All right, let's get one more somewhat complicated problem, and then that's going to do it for this video. All right, as I promised at the start of the video, we're going to do a deviation table problem that involves interpolation, because that's arguably the hardest type of problems. The rest of these are just really plug and chug. So let's start with our G, G, E, T, V, M, D, C. We are heading 142 by gyro. Gyro is 1 east. Variation is 12 west. And we're trying to find our compass. So we know that true is greater east, so 143, true lesser west, 131, true lesser west, so 155. And 155 falls between 160 and 165. So it's just a linear interpolation, so it's going to be 155 minus 150 over 165 minus 150 is equal to x over the difference between these two deviations, which is 1.5 minus 0. Now, obviously, if that wasn't 0, you would, do it as needed. So that's going to end up being 5 over 15 times 1.5, and that's going to give us 0.5 degrees west. We know it's west because we're going west. If this was east, and then we went west, you'd have to, you know what I'm saying. So So apply that here, 0.5 degrees west, true is lesser west, so 155.5 degrees is our compass heading. That's pretty much it. Obviously there's different versions, the wind can be coming from different directions, so just things you gotta be take into account. But everything covered in this video is pretty much all the basics. This is gonna be the last TerrNav video for a while, because of finals and such coming up. I might make one on set and drift with maneuvering boards if I feel like it and if I feel like I understand enough to make a video on it. If not, I'll see you when I see you. Bye.